Professor Dave again. Let's find dot product.
He knows a lot about all kinds of stuff. Professor Dave explains.
We now understand what vectors are, and we can do some operations with them. We can add and subtract them, and we can multiply them by scalars. But we also want to be able to multiply two vectors together. And this is not as trivial, because we have to understand what we mean by this operation. There are actually two different ways that we can multiply two vectors. And the first kind of multiplication will give us something called the dot product. Let's learn how to perform this operation. The dot product is fairly intuitive. If we have some vector a with components a1, a2, and a3, and another vector b with components b1, b2, and b3, then its dot product will be denoted this way as a dot b. This will be equal to a1 b1 plus a2 b2 plus a3 b3. It is very important to note that this is a scalar product. The dot product does not give us another vector. It takes two vectors as an input and gives us one number as an output. For example, if a is 2, 4, and b is 1, -3, then a dot b is equal to 2 times 1 plus 4 times -3, or 2 minus 12, which gives us -10. Because the dot product involves simple multiplication, it has very intuitive properties. A dot b equals b dot a, because it doesn't matter what order in which numbers are multiplied. The distributive property also holds, and a dot the sum of b and c, or a dot the vector that results from adding b and c, is the same as a dot b plus a dot c. A scalar times a vector involved in a dot product is the same as the scalar multiplied by the dot product, or the other combination of scalar and vector involved in the same dot product. A dot a is simply the length of a quantity squared. And the zero vector dot a is the number 0, because we are just multiplying each component of a by each component of the zero vector, which are all zeros, and then adding all of those zeros up to get 0. The dot product also crops up in an interesting theorem, which says that for two vectors, a and b, a dot b is equal to the length of a times the length of b times the cosine of the angle between them. This means that if we want to calculate the angle between two vectors, we can simply bring these vector lengths to the other side of the equation, and we get cosine theta as being equal to a dot b divided by the product of the vector lengths. This is one of the reasons the dot product is useful, as it gives us a great way to calculate angles without doing any trigonometry. Let's give it a try. What is the angle between vector a with components 2, 2, -1, and vector b with components 5, -3, 2? Well, first, let's find the length of each vector. For a, that's 2 squared plus 2 squared plus -1 squared, all under a square root. We simplify to get 9, and then take the square root to get 3. For b, we get 5 squared plus -3 squared plus 2 squared under the square root. We simplify to get 38, and we can just leave this as root 38. Now let's perform the dot product. Multiplying the corresponding components, we get 2 times 5 plus 2 times -3 plus -1 times 2. That's 10 minus 6 minus 2, or 2. So plugging everything in, we get 2 on the top, and then 3 times root 38. That is equal to the cosine of the angle between the vectors. To solve for the angle, we just take the inverse cosine, and since this is a pretty ugly number, we just plug it into a calculator to get some decimal and press the inverse cosine button. That gives us around 1.46 radians, which is about 84 degrees. This operation leads us to another definition. We want to understand that if the angle between two vectors is half pi radians, or 90 degrees, these vectors are orthogonal. This pretty much means the same thing as being perpendicular to one another, and an important thing to note is that any two orthogonal vectors will always give a dot product of 0 because the cosine of half pi is 0. This means that if you are computing a dot product and you get 0, those two vectors are orthogonal. So that's what we need to know about vector dot products, which represent one way that vectors can be multiplied. The other way, called the cross product, is more complicated, and one interpretation will require that we understand how to use matrices. Matrices are the plural of the word matrix, which apart from being a super cool science fiction movie, is a construct that is ubiquitous in the study of linear algebra. So let's move forward and begin to study this new subject. But before doing so, let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.